Hello everyone, my name is Sayed. Today we are going to discuss about voice gateways. Okay, it's a very big topic actually, the voice gateway. There are many things comes. I'm taking this as a different chapters here, different topics here. So even it's not possible to complete this voice gateway in one class or two class this one. So probably we are going to be complete in three classes this voice gateway, three or four classes. Okay, in this chapter we are going to be understand what exactly voice gateways, then what hardware and software platform we have this one, and understanding and configuring unlock signal and its ports here this one. Till the unlock ports we will discuss. After that, digital we have that I'll be taking separately, and practicals also. And after that, we have the concept of the digit manipulation that I'll take it a separate class this one. So this is how three different topics will make it, or chapters will make it under the voice gateway here this one. Okay. Then yes, dial pair also it's very important. We'll be discussing what is dial pair, how many types of dial pairs we have, and what is the inbound and outbound dial pair matches criteria and why we require. Okay. Then understand what exactly voice gateway. What is this gateway? Why do we require this gateway? Okay. Now you have the router. What is the primary function of the router?
Different networks.
The primary function of the router we use for the routing, for the data to be processed. The same router you can be used in your voice network. Means in this collaboration network, same router we can be using. Then that router, it's called as a voice gateway. We have gateway, voice gateway. So which device will be act as a gateway? Router will be act as a gateway, because gateway means it will be connecting to the two different network, private network and public network here. Now, primary we use this router only for the routing purpose. Okay, selecting the best path, reaching to the destination, and carrying your data traffic. Now we are using the same router for the voice traffic to be processed. So for this, we got voice gateway here. Router act as a voice gateway. Primary function of router is to do the routing. Few routers having the ability to process of voice traffic. Means again, not all the routers. We have some few models. We have this one. Only that routers we can use it as a voice gateway. If you go to the production network, you cannot take whatever the router and you want to be implement into the voice network or video network. It's not possible. Okay. Only the Cisco recommended hardware we have to be used this one. And then it is called as a voice gateway. Got it? Now what is voice gateway? Okay. For an example, see, this is my headquarter here. This is my headquarter I'm having. So this is the CUCM cluster. Then these are the IP phones which is connected here. And this is the branch office also I'm having here, this one. So in the branch office also we have the phones, but this branch office phone also registered under the headquarter. Okay. So what type of deployment model is this? Multi-site with the centralized call processing model. See, because in the branch also we have the phones that's registered under the headquarter, and always it will be registered via IP WAN. Through the internet, it will be registered this one. So for this type of deployment, we call multi-site with the centralized call processing here. Now, if you want to communicate, okay, to the branch office, or you want to communicate to the PSN. For example, if the branch is, the WAN is down here, this one, then automatically call has to be routed via PSTN here. So PSTN, public switch telephone network, or there are some customer or business partners. We don't have the voice communication. We have to connect through the PSTN here. If you want to connect to the PSTN, how the call will be routing? See, this is your CUCM cluster. This is the switch. This is the IP4. Okay, from here it will be connecting. See, whenever you want to communicate, okay, the connectivity also you require, right? From one device to another device, you use any device. Either you can use IP phone, laptop, computer, server, any network device you use this one. Okay. Between the devices, if you want to be communicate, connectivity is required. Without connectivity, it's not possible to communicate. Either you can go with the wired connection or wireless connection, any connection. Connectivity is important. For an example, here there is one user. Okay. So this is the guy. Now you want to communicate to this guy here. Okay, this number is 98454993887. Okay, Okay, this is something number I'm having. This is the mobile number. From this, for example, it's having the extension 1001. From this mobile number, I want to dial to this number. So what happened here? So whenever I'm dialing, the call goes to the call manager. Now call manager, it's going to be check it out. What type of number is this? Oh, this is the external number. Okay. Now actual the call has to become from the call manager to this gateway. This is the router. From here, it has to come to the PSTN. Then it has to be connected to this user. This is how the connectivity we have this one. Now, the question is this, how this call manager comes to know that who is my gateway? Okay, there is a separate configuration. There is a concept of route pattern and everything. Here we have to be configure who is my gateway. Then this CUCM is sending the call to this router here. Now we are discussing about this router here. In this chapter, completely, either we are not discussing about the call manager or the IP phone switch, nothing here. Completely, whatever the gateway we have, right? This one, about this gateway we are going to be discussed. This is called voice gateway. Why? Because so when the call is coming here, now this router having the ability to process the voice traffic. Hi, hello, how are you? This is the information you are sending this one. Now, this is not a data traffic. This is what? Voice traffic. Now, this router has to process this voice traffic here, this one. Okay. Now, you cannot take every router and keep it as a voice gateway. It's not possible, this one. Only few series of the router we can be take it and we can be configured as a voice gateway. So now this gateway here you can see one end it's connected to PSTN, another end it's connected to IP WAN, and another end it's connected to call manager. See, now this gateway is connected to CUCM, IP WAN, PSTN. Got it? So now I can receive the call from CUCM also. Through the WAN also I can receive the call. Through the PSTN also I can receive the call here, this one. Or I can send the call to IP WAN. I can send the call to the PSTN. I can send the call to the call manager also, this one. Got it? So this is what? Voice gateway. See, every location, how many sites you have? In every site, it's a mandatory one voice gateway we require, minimum one gateway. Generally, what happens if it is a critical, we go with the 2-2 router, this one. Why? Because we have only one router. If that router goes down, the entire network is down. It's not possible to make external call, and even it's not possible to receive the incoming call. From the outside, someone is dialing. Okay, the call is coming to the provider. From the provider, it has to come to the my office. So my office gateway is down here. Then it's not possible. So that's the reason for redundancy purpose, what we do, always we go with the two routers we have to be configured. But again, depend on the countries. In which country you have an office, based on that every location we are not installing two gateways. Example, you have a business in US, Canada you have. Then you have a business in UK. Then you have a business in Asia. Then you have a business in New Zealand, Australia, here, this one. Okay. In US, UK, then Australia, New Zealand, what happened? We have a concept of centralized deployment on the gateway level. On the gateway level, centralized deployment, we have this one. Every location, they are not going to install the gateway. And it's not mandatory. Okay. So how exactly that design comes and how exactly they are defining and configuring that one, we'll be looking into this voice gateway. There is a separate topic. Again, the cube we have. Okay. In that, we are going to be discussed about the cube deployment model. We'll be discussed on that one. Okay. The countries like Asia, you take any country in the Asia. So you talk about Singapore, you take India, Hong Kong, Japan, okay, China, Dubai. In these countries, we don't have that facility because of the TRI rules. We don't have the facility. It's a mandatory. We had to keep one local gateway. We had to mandatory. We had to keep one local gateway. See, generally we have a concept of SIP trunk. Okay. In India also we use the SIP trunk, but that's technically it's not a SIP trunk. It's a PRI trunk. Okay, but still people they call it what as a SIP trunk, they'll call it, but actually that's not the concept here. This one about this type of connectivity setup deployment model will be learning in the cube, the completely in the cube we are going to be learn here in this one. Okay, but Yes, rather than this. So any other location, if you take, or if you have, if that location is very much critical, in that scenario, what we are going to do, this one, we are going to be install the multiple routers. We are not going to depend on one single router, because if anything happens to the one gateway, the complete network goes down here, this one. Okay, now we'll be concentrate completely on this voice gateway. This is the another product. See, CUCM is the one product, okay, which we have learned what is CUCM, its deployment model, its cluster, its hardware, software, installation, configuration, access, registration, users, and everything. That's the one product. Okay, the voice gateway is the another product here, this one. So now we are going to be concentrate completely on the voice gateway, what different functionality, what different features, what different services, this gateway in which scenario, where and what purpose we are going to use this voice gateway, we are going to be learning this one. Getting? Okay. Let's see the what different functionalities of the services this voice gateway can be provided. Trunking signal system. Yes, see, for example, from my IP phone, the call is going to the call manager. From the call manager, it comes to the gateway. See, from the call manager, directly it's not possible to connect. See, from the CUCM, directly it's not possible to connect to the PSTN, or it's not possible to connect to the WAN here, this one. Got it? So always we have to connect through voice gateway here. See, now CUCM will be sending this call to this voice gateway. Now this gateway have the ability to connect to the PSTN or IP WAN, this one. That is what trunk signaling system connect to PSTN. Digit manipulation. In general, manipulation means what? Modifying, changing, something like this one. Now, digit manipulation means you are modifying the numbers here, this one. Yes, here we had to manipulate the numbers. If you remember, we have registered the IP phones. We have assigned the extension also. How many digit extension we have assigned? 7-digit extension we have assigned, right? 7-digit. That is the internal extension. You go to any organization internally, either 4-digit, 5-digit, 6-digit, or 7-digit. It comes that one, but that's not a valid number. Okay, the whatever the internal number we have, that's not the valid number here. This one. So if the valid number comes with the E.164 format, again, I'm discussing later about the PSTN and its numbering plan here, this one. So whenever if I'm calling, okay, so I'm dialing the complete E.164 format. When the call is coming, for example, this is the call is coming here from the PSTN and it's hitting to the gateway. In the gateway, what we are doing, we are manipulating that number. We are changing that number. How we are changing the number? From the 10-digit, we are changing to the 5-digit or 6-digit or 7-digit. When you are dialing, you will be dialing 10-digit. Here, you are converting that to the 5 or 6 or 7-digit and sending that one. That is called digit manipulation here. So we have a different types of digit manipulation. There are different mechanism, methods, or criteria we have to manipulate that number. Okay, so you can manipulate incoming also, outgoing also, this one. Outgoing number you want to manipulate, incoming number you want to manipulate, calling number you want to manipulate, call number you can be manipulate that one. We have a separate topic on that digit manipulation. So we'll be discussing on the day 3 of this session, the what is this digit manipulation and how we can do. And again, that manipulation we are doing on gateway. Okay, IVR system, interactive voice response. Generally, whenever if you dial the any toll-free number, the moment you dial, you will be getting the greeting, right? You can hear one voice. Welcome to ABC company. Press 1, press 2, press 3, press 4, this one. That is called IVR, interactive voice response. There are in some scenarios, this IVR system we can be configure on the gateway also. Generally, for this IVR system, we have a different setup depending on how big your infrastructure. So you can be configured on in your Unity connection, you can be configured in the call manager, but in a call manager, there is a concept of hunt palette, but where there is no kind of IVR system. But yes, Unity connection, the call handler we can be configure, or we have a auto attendant, or we go with the contact center UCC, UCCE, we can be configure. That is a separate, setup we have, separate infrastructure we have for that one. But still, the first call will be hitting on the gateway where IVR system, if you want to be configured, we can be configure that one. Next, TDM based voicemail system. Yes, you want to be receive the mail through the PSTN, that is called TDM time division multiplex. So whenever if the call is receiving from the PSTN, again in the PSTN, when you're connecting, you have different types of connection, analog connection or digital connection. That is what we'll be, learning in this chapter. What is this analog and digital? That one. For that, we call it as a TDM technology it uses in the digital connection. Through that, through this PSTN connection, we can receive the mails also. Again, the mail to receive here, the TDM is going to terminate on the gateway. The connection, whatever the connection we have. Work with redundant to Cisco UCM. What is this here? Work with redundant to the Cisco UCM. See, this is my branch office. These phones are registered where? In headquarters, the phones are registered here. Always it will be communicate via WAN, right? For example, it will be, this is how the connection happens. This is how it will be connected. What happen if this WAN goes down?
The alternate routing or SR.
Exactly. So we have a concept of SRST, survival remote site telephony. Automatically, what happened this one? This phone goes to the local gateway. This is my local gateway. Now, if this phone is unable to communicate or contact to this CUCM, this phone goes to the local gateway and it will be get registered under the SRST mode, survival remote site telephony. So where on the gateway it's registering. So that is what redundancy to the call manager. Now call manager we have, suppose if the call manager goes down or it's not possible to reach or communicate, then automatically this gateway will act as what? Redundancy to the call manager, right? So this is what SRST, survival remote site telephone. Fax and modem support. So you have the fax call or modem call. That also will be, so whenever the fax also coming through PSTN only provider, then it has to be terminate that calls on the gateway here. For this also we can use queue signaling support. Generally this queue signaling we use before to the CUCM, we were having the concept of PBX, private branch exchange. Okay. If you have a two different vendor PBX system, for example, one is a Nortel PBX, another one is a Alcatel PBX. Okay. Earlier we were having the PBX. Why now we don't have the PBX system? Before to this unified communication, the PBX system was there here. Now, between the two different PBX system, if you want to be communicate, then we require some protocols. Okay. We were using the queue signaling protocol here. Now, this Cisco voice gateway also have the ability to support this queue signaling protocol. Suppose from this router, if you want to connect to the any PBX system, if the queue signaling protocol is required to be communicate between this gateway and the PBX system, then it's going to be support the QSIG protocol. DTMF relay capabilities we have. Okay. So about this, we'll be learning. So here I'm giving only the overview, what exactly all this, features here. But later on, we'll be learning one by one here. There are many things comes and many troubleshooting comes and many interview questions comes in this one. So DTMF dual tone multi-frequency here. What happened here? You are calling to the toll-free number. When you are calling to the toll-free number, okay, once or not only toll-free number, any number you call. Once the call got established, now you are speaking, your real-time voice traffic is flowing here there. In between, if you dial any number, it will not carry that number. Okay, it will not carry that number. But in case of IVR system, you are dialing the toll-free number, IVR already answered the call. Okay. After answering, it's asking you to press 1, 2, 3. Right. Once the call got established, in general, okay, if the user is dialing any number, it will not carry. But in this case, it has to be carried. Because if It's asking to press 1, 2, 3. If I'm not pressing 1, then what happens this way? It's not possible to reach to the particular service. In this case, it has to be carry the dial digit after the call is connecting. So that is what RTP we have. Okay. Again, I'm giving only overview here in this one. So to carry the dial digit after connecting the call, then we require the DTMF. It has to be configured manually. The DTMF has to be configured on the PSTN also. The DTMF has to be configured on the gateway also. Suppose if your DTMF is not configured or the not working, then whatever the inputs you give, it will not carry that inputs. So that is what the DTMF relay capabilities that we are configuring on the this voice gateway. Got it? So these are the different functionality we have. Yes, it will be act as a gateway protocol. These are the protocols, H.323 SIP, MGCP protocol. We have this one. Again, now I'm dialing the number from my IP phone. The call is heading to the COCM. Now from the COCM, the call has to be forward or connect to the gateway. Now how this COCM can speak to this gateway? Or how this gateway can speak to this PSTN? Or how this gateway can speak to this provider? Then between this gateway to the providers or to the call manager or from the provider to the gateway or call manager to the gateway, if they want to communicate, we have to implement some protocols. We have to implement some protocols. So you can implement any of this one protocol. H.323 protocol is actually dot here, not H323, H.323 SIP and MGCP protocol. This one. Got it? So again, this is very big topic. H.323. It takes minimum 2 days, SIP 2 days, MGCP 2 days to know about, to configure and everything. This one. Okay. So all this protocol we can be implement on this gateway. Again, the skinny protocol also we can be implement. Skinny also we have. That protocol also we can be implement. SCCC. Clear? So this is about the functionality of this voice gateway. Okay. It plays very major role actually for the calls. Okay. For external calls to receive the incoming call from the external. Okay. Then after for any whatever it may be. Okay. It plays very major role and many issues you'll be getting. Any calling issues you have in a production network. Most of the time issues on the gateway, not on the call manager, not on the phone. Okay, yes, there is an issue with the phone also. Maybe the issues comes with the call manager also. But majority of the time, if you get any calling issues, like calling issue, call drop issue, call quality issue, that comes on the gateway level. So that is the reason the gateway is, it's very, very important. Yeah, here every product is important. So what happened if you go to the interview, you'll be get many questions from the gateway. Call is not coming, call is not going, call is getting dropped, call is not connecting, call is connecting to the gateway after the call is not connecting to the call manager, or call getting dropped. There are many issues comes here in this one, or voice quality issues comes here. Okay. And calling issue means it can be anything, one-way issue, it can be. So many things comes here. Even the interview, they'll expect few questions. You can expect few questions from the gateway. And in the obviously in the production, when you are working, any call related issues if it comes. So the maybe the issue with some other product also, but most of the time it will be issue on provider or gateway. So this is about the Cisco voice gateways. Clear? Got it now. What is this voice gateway and why we require this gateway? Supplementary services support hold transfer conference. See what exactly here. So this is an IP phone. External, there is one another phone. I'm calling from external to internal. Now call is connecting via this gateway, right? Provider gateway. This is how it's connecting. So after that, this internal user putting the call on hold. This user transferring the call. or this user putting the call on conference. In that scenario, what happened? Even this router has to be support all these services. Your IP phone supports, call manager supports. At the same time, even your gateway has to be support for this services. This is called supplementary services. This one. If the gateway is not supporting for this supplementary service, what happen? Your conference call will not work. Your call transfer will not work. Hold will not work. So that's the reason now it is having the ability to support this all types of calls here. But yes, for the whole transfer conferencing, again, we have a separate concept of media resources. In that media resources, you will be learning about what is media resources, software-based, hardware-based media resources. How many types of media resources we have, what is the use of that one, how we can be configured, and everything will be looking into that. So this is about the functionality or the overview of the voice gateway. Any questions? Okay. Next, we'll discuss about the hardware platform. Now you want to use that router. Which series of the router you can use as a voice gateway? There are many series we have in the Cisco. You cannot take whatever the series and you want to be use it that as a voice gateway. It's not possible. Only the Cisco recommended series of the module we have. Only that series you can use. Okay, as a voice gateway here. Okay, let's see what different series we have. First, ISR G1. G1 means generation 1. ISR stands for Integrated Service Router. Any of 18 series, 1800, 2800, 38. XX means it represents any number. For example, 1801, 1810, 1811, 1821, 1841, 1845, 1845. All this series comes under the ISR G1. 1800, 2800, 3800 series. Okay. All this comes under what? Generation 1 router. Next, we have ISR Generation 2 router. Okay. 1900, 2900, 30. It's easy to implement. 18, 10, 28, 10, 38. Here, 19, 29, 39. Any of the series comes, that's the ISR Generation 2 router here, this one. Okay. Like, 2 months back, many of the companies, they were using the 3900 series router. Many. It's important you should be know in a production network what exactly the model or series of the router you are using. Okay. This 3900 series router we have right, ISR Generation 2. So it's an end of life now. End of life. When is the end of life? 31st December 2022. Okay. If anyone is using before to this, any generation 2 router, okay, it's a mandatory, they have to migrate to the new routers. It's a mandatory. Okay. Suppose if you are not migrating to the new router, what happens? That's it. So it will be working. Something is not working and you are troubleshooting. You are unable to troubleshoot. Then what you are doing? Then you are contacting to the TAC. Okay. The TAC will be checking what series of the router, what is the issue, what is the model. Then straightforward, they will tell that one, this is the end of life. Okay. Now we are not going to be support that. So that is what 3900 series. The end of life was 31st December 2022. Now this ISR Generation 1, Generation 2, we are not using. It's no more. But still I have given here only for your knowledge that one. Now the latest router is ISR Generation 4. You go to the any company, irrespective, they are using this ISR Generation 4 routers. Okay, we have ISR 4221, 4331, 4431, 4461. What is the difference between the 221, 331 means? So here configuration is the difference here. Only the configuration. Example, in the laptop, the processor, i3, i5, 7. What is the different? Threads are different, cores are different here, right? Speed is different. Here, like example, the whatever the resources comes, like a RAM and everything we use, that resources comes differently here, this one. So if you want to know more about this ISR generation routers, Here we go, this one. So Cisco 4000 series integrated service router. If you Google it about this one, okay, this is a Cisco document here. You can see that one. So this is how it looks. The router. Can you see this one? The routers we have. Okay, here you can go and see about the document, models, downloads, many things comes here in this one. See 4221, 4321, 4331. You know about in detail about this router, something. So you just click on that one, 4461 integrated series router. See Cisco 4461. So router here. You can be look about the data sheet, about its configuration. It's about her what resources it's having, everything, end of life. If it is if they have mentioned any end of life, end of support, everything we can be having in this. We can see an installation guide, everything we can see in that one. Every information you'll be getting from here. This one. This is about the latest is 4000 series gateway. You go to any company, what series gateway you have? 4000. At least you remember two models, 4321, 4221, something. So that's enough. Got it? ISR G1, G2 is not there. Now you don't ask me where is G3. Okay. Now it has Cisco designed that one such a way. So they have the G4 generation 4, that is a 4000 series router we are using. And also a few companies, they are using the ASR routers. Okay. So I'll be discussing later, maybe not in this chapter, or if it is possible tomorrow, we can discuss about that. See the router you have, right? That's an hardware. Inside the router, we required what?
iOS.
Operating system we required. For that operating system, we call iOS. Okay, in general operating system. But for that, we got iOS, Internet Operating System. So now in the router, whatever the operating system we have, different types of operating system we have. Example, in general, we have Windows operating system, Linux operating system, Mac operating system, Sun Solaris operating system, right? We have a different type. Similarly, in the router, what happened here? Okay, it's the same vendor, Cisco only. Depend on the series of the router, different operating system we have. ISR, EASR, IOX, IOX XR, Nexus OS. This is our different operating system we have. Every operating system they have developed for different series of the router. Okay. Now there is a ASR series routers we have. Example, ASR 900 series, basic model, ASR 1000 series, ASR 5000, ASR 9000 series router. This one. Okay. If you want to use not only this G4, if you want to use this ASR router also, you can use it. Okay. So that is what you can be see here. The ASR example. See, we have a different models here. 12 products we have. ASR 9000, ASR 9001. This is about the 9000 we have. Okay. Like 5000, we have a different model. 1000 ASR, we have a different model. So what is the difference here? There is a difference here. How many slots available, rack size 1U or 2U. 1U means it's very small, thin. 2U means double in size. 2 rack units. Okay. That's all. 10U, 10 rack unit. Can you see this one? Okay. There's a difference about this one. Okay. How much bandwidth it supports, maximum capacity, size, weight, chassis. Can you see this one? How much power it can be support. Fan, how many fans we'll get, airflow, how much, RSP, fabric authentication, what operating system, iOS XR. Can you see this one? Inside the software, what software we have? iOS XR. Okay, so that's what iOS XR. This is how different operating system we have this one. Okay, so this is how ASR series router also, if you want to be used. So ASR series also, it will be ISR, ASR routers. ASR also, it support as a voice gateway. But many of the company, they are using 4000. Clear? Okay, this is about the, here we have to concentrate more on the 4000 series gateway here. So again, we have the VG series gateway. What is this VG series gateway and why we require this VG series gateway? Now you go to any company, every company, what devices we are using as the end device? Exactly, right? IP phone, hard phone we are using, or the soft phone we are using this one. Soft phone, we have CIPC phone, we have a Jabber, we have WebEx, we have. So this is how we are having this one. Suppose in your organization, completely unlocked phones are there. Not an IP phone. Not an IP phone. Unlocked phones, you have this one. Now that unlocked phone you want to register under call manager. How you can register? Where you are going to connect that unlocked phones? Because if you have an IP phone that you are connecting on the switches. Analog phone is not possible to connect on the switch. Why? Because the analog phone, whatever the connection we have, RJ11. But the switch, we have the port RJ45. Ethernet ports, we have this one. Okay. So if you have only analog phones, that analog phone you want to be connect to somewhere in the network. For that, we have a separate device called VG series gateway. Okay, VG 350, 310, VG 320, 202XM, 204XM. This is how there are different. Again, this also a router. But in this router, we get multiple ports to connect your analog devices. Okay. Suppose these are the dedicated VG series gateway. Or you have 2939 or 4000 series gateway. Already the router we have, right? Voice gateway. What you can do in this 2939 4000 series gateway, there is one separate module you can insert. Means separate hardware you can be insert. Okay, for that we got high density analog gateway service model. You will be getting with the 72 ports and 48 ports. 48 ports means 48 analog phones you can connect. 78 ports means 78 analog phones you can be connect. So this is the separate module where you can be insert on in your 2939 and 4000 series routers. Okay, so it looks like this VG series gateway. This also a router. Okay, see here also we have the power button, console port, Ethernet port. Can you see here this one ports here? These are the analog ports of where you can be connect your analog phones. This type of ports. If you want to connect here, you can be connect. Like this Cisco ATA 191. I'll come back. Okay. Clear this one? Got it? VG port. Either you can use this VG series gateway or this you can use ATA. ATA stands for analog telephone adapter. Okay. This VG series gateway, if you have more number of telephones, analog phones, 20, 30, 40, 50. This is how these many numbers you have. What you can do this one, how the connectivity and connection comes. See this phone, all the analog phones we have connected to the VG series gateway. Okay. Now I am having a CUCM. Now this gateway is connected with the CUCM. Means actually it will be connecting to switch in between. From the switch, it's connecting here in this. Got it. Now you can configure this router from the call manager, and you can configure the numbers also from the call manager. So this is the VG series gateway you can use. For an example, you have only 2 analog phones or 3 analog phones or 4, very number, 2, 3 numbers you have. In that case, not required to go with this VG series gateway. You can go with this ATA, analog telephone adapter. See, this is the ATA. So this is one Ethernet port you have. This you are connecting to the switch. Where you are connecting? Switch you have connected. This is the RJ45 you have. Phones you are connecting here. Your unlock phones you are connecting. 2 ports you have. 2 unlock phones you can connect. Then this device can connect to the switch. From the switch, we have CUCM. Now in the CUCM, you can register this device. And under this device, whatever the ports you have, you can be as any extension. This is how the analog phones can connect to the call manager and get registered. We don't have any extra direct port or something like that. Either you can go with the ATA devices or you can go with the VG series. VG series for the bulk, more number, 10, 20, 30, this is our number you have, then you have to go with the VG series. Only 2, 3, 4 something you have, okay, then you can go with the ATA. 4 devices you have, purchase 2 ATA devices and connect that analog phones and get registered this ATA under the call manager. How you can be registered? If you go to the phone registration, device, phone, add. So there in the list we'll be getting right what series, there we get ATA. There we get what? ATA. ATA. Okay, select on that one what model ATA. So then after this also having the device name, you provide same information. It support both. Got it? So this is how it's going to be registered your analog gateway. And these are the different types of voice gateway. Yes, it comes. Got it? This is about the different types of hardware we have. Okay, on the gateway. Got it? Any doubts, any questions? Okay. So next we'll discuss about the analog voice ports. Before we get into the ports, we'll discuss about the analog signal. What is this analog signal and why we require this analog signal or how it works? Within the analog signal, how many different types of signaling methods we have this one? Okay. Any idea what is analog signal?
Continuous, it is not continuous.
It's a continuous signal. An analog signal is a continuous signal for which the time varying feature. This is the definition. What is the analog signal? Next, we have a concept of frequency. Okay. So what is frequency? The number of cycles per unit of time is called frequency. 4 cycles per second. Per second, how many cycles? 4. Then it's called 4 hertz. Okay. Now, wherever if you see Hz, then you have to be understand this is a frequency actually that one. Okay. How many number of cycles per unit of time is called frequency. Per second, how many cycles? 4 cycles. 4 cycles means?
4 continuous.
What is this 4 cycles means what?
0 to 3 0 to 360.
Okay. Analog phone line. It uses the property of electricity to convey the information. I'll come back on this one. Okay. For example, I'm having this phone, telephone. Okay. In this one, what happened? This is how we have, right? There will be a cable connected to this one. It goes to somewhere, we call it exchange office. You remember earlier, right? Whatever the telephone I'm having. Okay, that cable is coming from where? Exchange office. In general, that exchange office only the PSTN. We were calling exchange office, but technically it's called PSTN. That's a provider. Okay. From here again, there is another cable and there is another phone. Okay. Now I'm dialing from this phone to this phone. When you're dialing this phone, now your information, the voice information, it carries through this cable, right? Yes or no?
Yes.
It carries through this cable here, this one. Now, what type? See here, what happened? Now, is it possible any cable to carry the real-time voice? It's not possible to carry the real-time voice. It's not possible to carry your real-time voice. You take any cable, it's not possible that one. So what happened here? It will be converted into signals. Now, this cable having the ability to understand the signals, not your real-time voice. Okay. Now, who is going to convert your voice into signals? This telephone is going to be converted. Why we are using this telephone? You are taking this telephone and dialing the number, something. After the connecting, what happened? Hey, hi, hello, how are you? Something you are speaking. That is your real-time voice. And this device having the ability to convert your voice into electrical signal, because this cable will not understand the voice. It will understand only the signals. Now, what signals it understand? Analog signal here now. Obviously, electrical signal, but analog signal here, this one. Right? So, how exactly you can represent that analog signal? This is how. So, this is the scale. There are different formulas we have. Okay. So here you have the positive value and negative value. That's the volts. And this is the time, how much time it's taking here. And this is called, starting from here, this is a 0. Okay. Starting from here and completing this one here.
180.
Okay. Then again, from the negative end, it's completing. This is the 1 cycle. This is half cycle. Right. Starting from here and coming to this line, it's only half cycle. Again, it's a 1 cycle. Like this, how many cycles we require? 4 cycle per second. This, like this, it carries the 4 cycle. So maybe your value goes into the negative or positive side. Okay. How it goes negative, positive, or how many cycles comes in this one, depend how you are speaking. Depend how you are speaking here. This is how actually the voice, the waveform comes. Whenever you speak here. Okay. Generally what happens? Whenever we speak, the very first letter and last letter, we are going to pronounce very slowly. Example, hello. H, starting slowly. ELL, I am pressing more on that one. O, again completing slowly. So, suppose you are speaking loudly, very fast, more variants comes. If you are speaking slowly, less variants come this one. So, this is how actually the analog signal waveform comes here whenever you speak. But the representation is this one. If you want to represent the analog signal, this is how you can be represent. Okay, but actually it will be carried in the waveform like this. So who is converting this one? This telephone is converting. This telephone we are using not only to dial the number, also to convert your voice into electrical signal and vice versa. Again, you receive, right? For the incoming call, what you are receiving? You are receiving the signal. Again, that signal has to be converted into the voice. Who is converting this one? This telephone we are using to be converted into that one. Clear? Now, what is analog signal and everything? Now, to communicate from, see, one place to another place, what happened? We have a cable. The cable is connected this one. Now, inside that cable, we have the copper one. Whatever the cable you are using to connect this telephone, inside that cable, we have what? Copper wire here. Now, that cable is required electricity. That required what? Electricity. Now, who is providing the electricity? In your home, you are not providing electricity. You have only this phone. Exchange office is providing the electricity. The PSTN is providing the electricity. Because if the exchange office is not providing the electricity, it's not possible to carry. Because analog phone line use the property of electricity to convey the information. Convey means carrying, serving. Whatever you are speaking, hi, hello, how are you? Or whatever you want to receive that one. It's carrying the signals based on the electricity. Now, if there is no electricity, then phone is dead. Generally, you say, right, my phone is dead. Earlier, we were using phone is dead, phone is dead. How the phone is dead? They'll be switch off that electricity there. So then your phone is dead. It's not possible to call that one. Got it? Clear? Getting everyone this one? Okay. The next we'll discuss how this electricity works. Any idea how electricity works? You are from electric background. You also, right? You also. Mola also. You also.
Potential difference, right?
Huh? See, this four guys from electric background.
Potential difference.
See, I don't want technical answer, technical definitions. Again, we are not concentrating on this, or you will not get the job based on this one. Okay. I'm a layman. I don't know anything. So, can you explain me how exactly it works as a layman? Because layman has to understand. If the professional is there, if you are giving something definition or something, then they will understand easily.
We have to know your potentials.
Okay, even I don't know much. I know very basics here because I am not from that background. You have any doubts, any questions, please don't ask any questions about this electricity or something. Okay. One diagram I have taken. This is what? Battery. This is lamp is bulb. Okay. And I have taken two cables. One cable connected on one end of the battery, and another one is connected to the bulb, and another cable from the bulb, it's connected to the another end of the battery. If you take battery, you get one end negative and one other end positive. See, this is the positive end. This is the negative end here. So what happened here? Inside the battery, we have the electrons. Okay. So always electrons start from the negative end. Okay. It starts from the negative end. It coming to the bulb. Again from the bulb, it's going back to the positive end of the battery. Once the electron moves from the negative to positive, okay, inside this battery, chemical reaction happens. What happens? Chemical reaction. When this chemical reaction happens, the light is going to blink. This is the very simple definition. I know. Okay. More than this, you don't ask me anything. Got it? Always electron flow from the negative to positive. Now you can ask one question. Why can't electrons move within the battery from negative to positive? It's not possible. Why? Because it is made up with the two different materials. That is the one reason. Maybe you'll be having a multiple reasons. There is a one reason. Okay. So it is made up with the two different materials. There is no chance to move the electrons within the battery from one end to another end here. This one. So always it has to move from negative to bulb, bulb to positive, then chemical reaction, electrolyte we have inside. Okay. So that is a material. Chemical reaction happens. Once the chemical reaction happens, light is going to be blinked. Happy? Okay. Now, if you have any questions, Google it, go to the YouTube. Okay, learn from some expert and don't ask any question based on this electricity. Clear? Okay. My agenda is here to explain why electricity or how electricity works. Whenever you take the electricity, in the electricity, will get the pair of cable. Okay. The pair, one, it will be negative, one will be positive. Always, it will be start from the negative end. Always it start from the negative end. Means the communication or supply something, always it start from where? Negative end. That's it. Only to understand that one, I have explained how electricity works. Clear? Okay. Next, we'll go to the loop start signal. Okay. Again, this loop start signal, it's a part of analog signal. If you are using analog signal, within the analog signal, we get what? Loop start signal. What is this loop start signal and why we require? Say example, we have the phone here. This is my central office, means exchange office, PSTN. In general, we can call it central office here. We are grabbing a cable, okay, and connecting to the telephone here, this one. So can you see this one? This one, what is this? Receiver, generally we say, or cradle, we can say, handler, we can say, right? So this one. When you keep this cradle on the phone, it is called what? On hook. Hook. Okay. Now phone is in on hook. If you take this cradle, Then it's called off hook. Got it? What is on hook or off hook? So this is the cradle. Now it's on the phone, on hook. If I take it this, off hook here, this one. Got it? Okay. Now, this is the phone I'm having. Here. What happened? I'll take this phone off hook. The moment you take this off hook, you will listen one tone. You can hear one tone. Something, right? If you can hear that tone, that is called dial tone. That is called what? Dial tone. Now you can dial the number. If you are not hearing that tone, that means your phone is dead. You cannot dial the number. Even if you dial the number also, it will not carry. When I can hear the dial tone, I can dial the number, then that number will be carried to my provider. Then provider is going to be look what type of number, where it is connected, it will be routing that call here as well. Okay. When I take this AFO, then only I'll get the dial tone. Or if you have a speaker here, if the latest model phone you have, speaker if you use, then you get the dial tone here, this one. Now, who is providing this dial tone?
Electricity. Service provider.
The central office is providing. Who is providing this one? Central office, this one. Now the question is here, how this central office come to know that one the phone is off hook? When it will be providing this dial tone? Only when it goes to the off hook. When it is in the on hook, it will not providing. Only when it goes to the off hook, then it will be providing the dial tone. Now, how the central office comes to know about no phone is on hook or off hook? If it is a off hook, I have to provide a dial tone. How it comes to know that?
Loop.
Based on the loop start signal. Example. Actually, it will come like this. Inside the phone, see inside the phone, it will be like this. It will be like this. The cable. So we are getting a cable, right? It's a pair of cable. One is the negative and another one is the positive. So what happened? Continuously, it will be sending one signal, small signal to central office. Now this signal is coming from my provider. Again, I'm using signal is coming here. Now here is what happened. This is called circuit break. This is called circuit break. Okay. That means whatever the signal is coming, it's terminating here itself. This is the one concept. Suppose if I take this cradle, that means phone goes to the off hook. This circuit will be fall down. This circuit will be fall down. Now continuously I'm sending one signal, right? Again, the signal goes back to the central office. Then it's creating what? Loop. Whatever the signal I'm sending, okay? If the phone is on hook, inside we have a mechanism like circuit will be breaks. Okay. Then whatever the signal I'm sending, it terminating here itself. The moment I take the cradle, it will be fall down. When it is falling down, whatever the signal I'm sending, it reaching the inside the telephone. Then again, it's coming back to the central office. The moment it comes to the central office, then I'll understand. Okay, now I have to provide a dial tone. Then it's immediately it's going to provide the dial tone. You can hear and you can dial the number. It happens within a fraction of seconds, all these things. Got it? So that is what loop start signal. Now loop start signal we use to know the status of the phone, whether the phone is on hook or off hook. That's it. Loop start signaling is the typical signaling type used in the phone environment to know the status of the phone. Generally, we use where? On the home environment. On the normal end devices we use to know what is the status of the Phone, whether the phone is on hook or off hook. Because the phone goes to the off hook, immediately it has to send what?
Signal.
What types of signal? Dial tone signal. Signal, there are different types of signal. We have this one. Be specific that one. Dial tone here it will be sending. If you hear the dial tone, then only you can dial the number. You are not getting the dial tone, then no communication. Not possible to dial and no communication. Okay. Each analog circuit is a composed of pair. Pair means what? Two cables. One wire is ground or positive side of the connection, often called tip. The other wire is the battery or negative side of the connection. You have negative and positive. Always the communication starts from where? Negative end. Why? Because it uses the property of electricity. How electricity works? All the electrons, anything, it will be flow from the negative end. Got it? So this is about the loop start signal. It's very simple. Next, we have the ground start signal. Okay. What is this ground start signal? Now what happened? This is my office. This is not the home connection here. See, this is my office. Internal, I have multiple phones. Now I'm using key system. Key system is PBX system, not the unified communication. Earlier, we were having the PBX system. Okay. This is the central office. Now from the central office, I'm grabbing multiple connection. Means I have taken multiple connection. Why I have taken multiple connection? Depend on the business requirement. Concurrently, simultaneously, we want to make multiple calls. So multiple outgoing calls, multiple incoming call we require. So that's the reason we have taken multiple calls. Earlier in the PBX system, how we were having, whenever you take a connection from the provider, directly it will be connecting to that PBX system. Now you have what CUs here. Directly, we are not connecting that, whatever the connection we have from the provider, we are not connecting to the CUs here. We are connecting where now? On the voice gateway, we are connecting that one. Whatever the connection is coming from the provider, it's terminating where? On the voice gateway. From the gateway, it's connected to switch, CUCM. This is how we have. But earlier, PBX having the ability to connect directly to the provider here. So that's the reason key system is connected directly to from the central office here. Now, internally, I'm having some extension 5000, 5001, 5002. For example, I'm dialing one number 5001. The call will be hitting the key system. Key system, it will be looking. What is that? Means key system is like a CUCM earlier. Okay, it's internal number. The call is routing internal. Now, there is another number I'm dialing. That's an external number, not the internal number. There is one guy here. Okay. His number is 9845499381. This is something number. I am dialing this number. Okay, the call is hitting. Then it will checking the, oh, it's an external number. It will be providing the first connection to go outside. It connecting central office, connecting. Well and good. There is no issue. There is another guy here. Okay, calling to this internal extension 5002. So call is hitting to the central office. If the central office is providing the last connection, from this, it will be hitting the key system. It will be connected to the internal. Well and good. There is no issue here in this one. Now, what happens if when you are calling, okay, the central office, if the central office is providing the first connection, already first connection is busy. Okay, something communication is happening between 5000 and this user. So what happened in the central office is providing the first connection? What happened? It's like a one way. Collision happens. Accident happened, right? The traffic is coming from here, also traffic is sending here. What happened here? Okay. In general, accident we call it. In networking, we call it collision. If the two packets are colliding each other, it's called collision. Okay, that's a technical word. If the voice is colliding each other, then it's called glare. It's called what? In networking, if the packet are coming and colliding each other, that means accident. Then it's called collision. If the voice packets are coming and colliding each other, it's called glare. If the glare happens, what happens? Communication loss. If the communication loss, it's not possible to communicate. Got it? To avoid this type of glare, okay, we are using ground start signal. And this ground start signal, we are going to implement on the PBX system. What happened earlier, whenever if you have a multiple connection, if the key system is providing any of the connection, it's not going to be marked. It's not going to be check it out that one. Okay, whether that connection is online, offline, busy, not working, it's not going to be marked. It's not going to be monitored, or it's not going to be check the status of that one. So once you implement the ground start signal, what happens? It's going to mark what is the status of that particular connection. Okay. So through that one, we can be avoid this glare. Okay, to avoid this glare, we are using what? Ground start signal. And this ground start signal is designed to implement only on the PBX system. Got it? Clear? What is the ground start signal and loop start signal? Loop start signal, we use to know the status of the phone. Ground start signal, to avoid the glare, we use the ground start signal, and this glare we are going to implement on the PBX system. Okay. And this both signaling, loop start and ground start signal, it is a part of analog signal. It comes under the analog signal. Got it? So next we have, it is used to avoid the glare, and it is designed to implement on PBX system for large corporate environment. Okay. Next we have signaling events. So this signaling event, it's common for everyone, not only for the analog signal. Okay. Any type of connection, any type of telephone, you take it, it's a common here, this one. But we are discussing under the analog here, but generally now it's a common for everyone, this one. Even you take your today's mobile network, smartphones, here also we have the signaling events, we have this one. There are three different types of signaling we have: information signal, address signal, and supervisor signal, this one. Okay. What is this information signal, address signal, and supervisory signal here, this one? Information signal means what happens whenever you try to make a call. Okay. What is happening in the connection? It will be provide the information. That is what information signal. Information is what? It's providing the information. For example, you are dialing the number. That number is busy. How will you come to know that number is busy? You are getting the information, right? The number you have dialed is not exist or busy, right? That's all. Or some number you are dialing, switch off. How will you come to know? Some number you are dialing, it's in conference call or calling, everything. All this type of information comes under the information signal. It provides the status of connection. The different types of information signals are dial tone, right? That is also information. If you get the dial tone, then only you can dial the number. If you're not getting the dial tone, is it possible to dial the number? No. Then after busy tone. Then after ring back tone. Ring back means I'm calling to someone now, some other person. If the other person phone is ringing, how I'll come to know that one? Generally, we say ringing. It's a ring back actually. Actually, technical is what? It's a ring back. It's not ringing. Ringing means your phone is ringing, then it's ringing. Okay, call waiting tone. Then reorder or congestion tone. Okay, queue tone. Queue means you are into the queue. Sometimes whenever you call to some customer care or something, you are very important customer for us. Okay, please be hold on something. Okay, special information tone. Okay, sit tone. See, you are in the call. From the other end, if the call got disconnected, then you'll be getting T. That's not a busy tone. Okay, that's a special information tone. If the someone is disconnected, the call that one. Okay, these are the information tone. With this one, we can understand, right, what is happening in the connection. For this type of information or this type of signal, we call it information signal. Getting everyone? It's very simple we have. Okay. So I'll just finish this address signal and this one. Okay, address signal we have. See, we have taken the dial tone and dialing the number. When you are dialing the number, this dial digit has to carry to till provider, right? How it's going to carry that one? By using the address signal. It is used to send the dialing information. Dialing information means I have taken this one, I'm dialing the number. So what is the number I have dialed? It has to be carried this dial digit till the provider. For this, we use the address signal. There are two types of address signal. One is the pulse. Okay. It is used in old rotary dialing switch phones. Have you seen this type of phones? Trrr, make and break. See, generally, if I want to dial 1, I had to rotate here, then I had to leave. So when I'm rotating, this is the make. When I'm leaving, again, it's coming back. This is called break. So it will be working in the concept of make and break here, this one. Okay, in this type of phones, this is the rotary dialing. Whenever you are dialing, it uses the pulse signaling to carry the dial digit. Okay. Now we have the latest one is the DTMF, dual tone multi frequency here, this one. It has a touch tone pad and it uses 2 frequency tones per digit here, this one. Example, this phone you are taking, this whatever the number we have, this one, this is called touch phone. Okay, here we get, this is how the example, the frequency has given like this one. Okay, and this is not provided by me actually. See, this is the number you have, this one. Whenever you dial any single number, for example, 1 I am dialing, it takes 1209 hertz and 690 hertz. Dual. Even whenever you are dialing the number, t, you get right tones because of the dual tone, that one. DTMF. Okay, now we are using what? DTMF. Okay, addressing signal to carry the dial digits. In the old phones, we were using pulse. Clear? All right. Next, supervisory signal. After this, will be wind up today's class. Okay. Again, supervisory signal, we get 3 types of signal: on-hook signal, off-hook signal, to know whether phone is on-hook or off-hook. That comes under the supervisory. Ringing signal here. See, what is the ringing signal? See, this is my phone and this is my central office. We have a pair of cable which is connected to the telephone. When the phone is on hook, already the circuit are broken, right? If the circuit is broken, now already central office sending one signal. Okay. It's not reaching till the telephone. Of course, within the telephone, it's not connecting to the properly that one. So it's breaking, that it's terminating. Okay. Then if someone is ringing to my phone, how that ringing signal it sends? Means how the central office send the ringing signal to my phone? Because already it's sending one signal which is terminated because of the circuit broken. Right? Now how here it works for the ringing signal? So for the loop start signal, it use we have AC and DC current, right?
Yes.
AC or DC?
Alternating current, direct current.
Which one having the more voltage, AC or DC?
DC. Both having DC. Both are having DC.
Huh? AC having more, right? So for actually this one, what to say? For the loop start signal, it sends only the 12 watts of power, that one. That is the DC power. Not AC, DC power. DC power. But in case of ringing, it will use the AC power. Why? Because again, if it's sending the DC, it's terminating here because circuits are broken. Right?
Air contact.
Okay, now it will be sending what? AC power. Within this telephone, any telephone you take, there is one chip. There is one chip. It's called AC transceiver or receiver chip. TXRX, transceiver receiver chip. Every telephone will be having one chip that's called AC TXRX chip. And this chip is already programmed. What is the program? Whenever you receive the power, means if the central office sending AC power, this telephone having the ability to receive that power. Why? Because there is a chip, AC transceiver receiver chip. Now inside this chip, it's programmed that one. Whenever you receive the power, ring the bell. Already we have a bell. There is a hammer. Okay. There is a hammer. There is a bell. It's programmed that one. Whenever you receive the power, ring this bell. Now it's going to ring and sound comes out. When the sound comes out, you'll come to know, user come to, oh, someone is dialing, someone is ringing to my phone. This is how ringing signal works. Okay. Now all these 3 signals comes under the supervisory signal. Got it? Clear? What is voice gateway? How many different hardwares we have? What hardware in the production we are using? What is the difference? Then what is analog signal? Then what is how electricity works? What is loop start, don't start, and some other signaling like a supervisory signal, addressing signal, and information signal. All these are the signaling events. Okay. And this signaling event is not only for the analog. Now also we require, right? Now also my phone rings. Maybe different technology, different protocol we are using, but the concept is same here, this one. Clear? So all these things comes under the analog signal here. Before we wind up, you have any doubts, any questions?